Hello friends, in this video session I am going to discuss the concept of moment of inertia from the chapter Rotational Dynamics class 11. This is again one of the important concept from this chapter for all entrance exams after 12th class like JEE Mains, JEE Advanced, NEET, and now we'll go to moment of inertia. What is moment of inertia? Just before going to discuss about moment of inertia, we'll have some idea and inertia also. What is inertia? We studied about the inertia in translatory motion. Inertia is a inability of a body to change its state by itself. Let us suppose a body at rest. It wants to be in the same state until any external force acts on it. Automatically, its state cannot be changed by itself. It is in the state of rest, wants to be in the same state, or if it is moving with a constant speed, wants to move in the same speed until any external force acts on it. That is inertia. Simple definition of inertia is it is inability of the body to change its state by itself. This is called translation inertia. It is measured in terms of mass. More mass, more inertia, less mass, less inertia. Inertia actually nothing but in a chemistry you might have studied about inert gases. Their electronic configuration is ns2 np6, s orbital, even p orbital also fully filled. They don't want to participate in any chemical reactions because it is fully filled. Inertia nothing but almost it is equal to laziness. If anyone apply more amount of the force, apply the force, then it is ready to change its state. More mass, let us suppose there is a heavier object and there is a lighter object. If you want to set these two bodies into the motion, because already in the state of rest, definitely you need to put more effort on the body which has more mass to set into the motion. So inertia is measured in terms of the mass. More mass, more inertia, less mass, less inertia. How much force required to set the body into the motion? To calculate the force, definitely mass should be known. By knowing the mass, then only we can calculate the force. So once inertia is known, that is measured in terms of the mass. From that, you can calculate the force required to set the body into motion. Come to the moment of inertia. Moment of inertia is called rotational inertia. So amount of the force required. Here what is the difference between inertia and moment of inertia? For moment of inertia, even point of application of the force also important. Where you are applying a force. So it is rotational inertia. It doesn't want to change or increase the number of rotations or to decrease the number of rotations until external torque acts on it. That is the difference between inertia and moment of inertia. How to calculate moment of inertia? Moment of inertia is a scalar quantity that measures the rotational inertia of an object about a specified axis equal to the sum of the products of each mass element by the square of its perpendicular distance from the axis of rotation. Let us suppose this is a textbook definition. You know this object, let us suppose ring, you can take the ring rotating about its own axis. You want to calculate moment of inertia of a ring about this axis. Select one small line element whose mass is dm, which is at a distance r. Then moment of inertia of that particular thing is dm into r square. So again, if you can select all the points on the circular ring and multiply mass into square of the distance, you will get total moment of inertia of that particular object. If you go for the integration process, then you can write I is equal to m into r square. So it is the product of each mass element by the square of its perpendicular distance from the axis. So moment of inertia depends on mass of the body and dimensions of the body. Apart from that, position of axis of rotation also. Let us suppose ring of mass m and radius r. Moment of inertia of a ring about the central axis. moment of inertia ring about the perpendicular tangent will be different. Because with respect to the central axis, mass distribution is different from the perpendicular tangent. So it depends on mass. It depends on mass. Depends on mass distribution also. And depends on position of axis of rotation and depends on the temperature. Depends on mass distribution, depends on axis of rotation, position of axis of rotation, and shape and size of the body, finally temperature also. How it depends on temperature? Once the temperature increased, then its dimension changes. Once the dimension changes, then relative positions of the particle also changes. Nothing but mass distribution will be changed. Once the mass distribution changes, ultimately moment of inertia changes. So why to calculate moment of inertia? Without knowing the moment of inertia, we cannot calculate torque required. Torque is equal to I into alpha. Like force is equal to ma, your torque is equal to I into alpha. Without knowing the moment of inertia, we cannot calculate the torque required to increase the rotations or to decrease the rotations. So whatever the role played by the mass in translatory motion will be played by the moment of inertia in rotational motion. So now we have moment of inertia of different objects about its own axis. What is its own axis? Own axis nothing but passing through center and perpendicular to the body. Solid sphere, it is 2 by 5 mr square. Hollow sphere, 2 by 3 mr square. Solid cylinder, mr square by 2. Solid disc, axis along the diameter. Diameter is talking about diameter in the plane. Solid cylinder about the diameter, nothing but through its plane, nothing but about this axis. Okay. Then thin rod about one end and perpendicular to that. And these are the list of the moment of inertias about their own axis. This you have to remember. The problems don't expect, the moment of inertia problem don't expect only for central axis. Once you know the central axis moment of inertia, you can calculate moment of inertia about any axis using this. We have two theorems. One is perpendicular axis theorem. Second one is parallel axis theorem. First we will discuss about the perpendicular axis theorem. If you want to calculate moment of inertia of a disk, let us suppose this is a disk. Moment of inertia, this is a disk. This is the own axis. Own axis nothing but passing through center and perpendicular to the body. We know that in the list given, that is moment of inertia of a disk is mr square by 2. But I want to calculate moment of inertia of a disk about the diameter. Then how to calculate? We can calculate moment of inertia of the given disk about the diameter using perpendicular axis theorem. What is perpendicular axis theorem? If we select here, this is a rigid body. I have selected 3 axes, Ix, this is x-axis, this is x-axis, Ix nothing but moment of inertia of that particular body about the x-axis. Iy, moment of inertia of that particular body about y-axis. Iz, moment of inertia of that particular body about z-axis. Then what is perpendicular axis theorem? Perpendicular axis theorem states that Iz is equal to Ix plus Iy. How to apply this actually? Before going to the statement, we need a 3 axis. 3 axes x, y and z. Three axes should be perpendicular to each other. Point number 1. Point number 2, 2 axes, either any x, y, z, from these remaining 3, 2 should lie on the plane. This is lie on the plane according to the picture. This is x-axis, lie on the plane. And this is y-axis, also lie on the plane. Z-axis is perpendicular to the plane. Then perpendicular axis theorem states that sum of the moment of inertia of a rigid body about 2 axes, two axes which are lying on the plane, meaning Ix and Iy. Ix is a moment of inertia of a object about an x-axis. Iy is a moment of inertia of object about y-axis. sum of these two is equal to moment of inertia of a same object about the z-axis. About the z-axis. This is a perpendicular axis theorem. 3 axes required. Out of 3, 2 should lie on the plane, and third one should passes through the point of intersection of the first 2 axes. Point of intersection of the first 2 axes. Then you can write Iz is equal to Ix plus Iy. X and Y on the plane and perpendicular to each other. Z-axis is perpendicular to the plane and passing to the point of intersection of the first 2 axes. Then moment of inertia about z-axis, which is perpendicular, is equal to sum of moment of inertia of object about x-axis and y-axis. So come to our disk, how to calculate it. I can calculate, say this is a disk whose mass is m, whose radius is r. I want to calculate moment of inertia of a disk about the diameter. So I can say this is x-axis and this is y-axis. This is own axis, z-axis. I cannot draw the perpendicular one. That's why I kept like this. It's a top view. You know that I can write here Iz is equal to, its own axis is equal to Ix plus Iy. According to the picture, Ix is the diameter, x-axis also diameter, and y-axis also diameter. Z-axis is own axis, central axis, that is mr square by 2. This value already I have given in the list. From there you can calculate. From here you can calculate moment of inertia of a disk about the diameter is mr square by 4. Like this, we can calculate moment of inertia of a given rigid body about axis by using perpendicular axis theorem. And one more theorem, that is parallel axis theorem. See, this is before that perpendicular axis theorem statement is this. The perpendicular axis theorem states that any flat planar lamina moment of inertia about an axis perpendicular to the plane, that is z-axis, passing through the O, that is O is the point of intersection of the first 2 axes, is the sum of the moment of inertia about 2 mutual perpendicular axes, that is x and y. Then mathematically you can write as Iz is equal to Ix plus Iy. Now moving to the parallel axis theorem. See, to apply the parallel axis theorem, let me write the statement. Okay, what is the statement? Mathematical statement. According to this, Iaa prime about any axis is equal to Ioo prime. Usually we write Ioo prime, we write as Ig. Ig nothing but passing through the center of gravity plus m into h square. What is h square? H is the distance between the 2 axes. Now how to apply? Here 2 axes required. Point number 1, 2 axes required. Out of 2, one should passes through a center of gravity. One should, that is Ioo prime. Here according to the picture, one should passes through a center of gravity. Second one parallel to that. Passes through a center of gravity means it may be perpendicular to the plane, it may be parallel to the plane, doesn't matter. You can calculate about any axis moment of inertia which is parallel to the Ig. Ig nothing but in this picture Ioo prime, nothing but passing through the center of mass, may be parallel to the plane, may be perpendicular to the plane. This is the parallel axis theorem. Parallel axis theorem is moment of inertia about any axis is equal to sum of the moment of inertia about an axis passing through the center of gravity and product of mass of the rigid body and square of the perpendicular distance between the 2 axes. The given 2 axes should be parallel to each other, and out of 2, one should pass through a center of gravity that may be parallel to the plane, may be perpendicular to the plane. This is the statement. Now we'll solve few more questions based on the moment of inertia, parallel axis theorem and perpendicular axis theorem. To get more clarity on the concept, to improve your marks before your final exams, watch these videos, do subscribe, Time YouTube channel, that is Time for IITJEE NEET. A uniform solid sphere with radius R and length L. Let me draw that. Solid cylinder whose radius is R and whose length is L. Moment of inertia I1 about an axis passing through a cylinder. Nothing but about this axis. You know, moment of inertia of a solid cylinder about its own axis is mr square by 2. Okay. A concentric solid cylinder of radius r by 2 and length L by 2 is curved out, meaning some portion, meaning like this much part curved out from the given sphere, whose length is L by 2, whose radius is r by 2. Okay, curved out of the original cylinder. What is I2? I2 is a moment of inertia of a curved portion, curved out portion of the cylinder. So you can write that is also cylinder. I can write I2. That mass we don't know, we can calculate I prime, M prime. Radius you only mention r by 2 whole square by 2. Now only thing is M prime you should calculate. How to calculate M prime? Based on the mass distribution. So total mass of the cylinder by total volume of the cylinder. Volume of the cylinder is pi r square into L is equal to uniform solid cylinder you only mentioned in the problem. So mass of the removed part M prime, volume of the removed portion M r by 2 whole square, length L by 2. So you can write as M and pi r square gets cancelled. This goes 8 M prime, 2 2's 4, 4 2's 8 goes to numerator. So M prime is equal to M by 8. Now you can write, substitute the value here. I2 is equal to M by 8, R square by 4, 4 into 2, 8. So how much you will get it here? MR square by 64. What he asked? I1 by I2. So if you write I1 by I2, which gives you MR square by 2. This is MR square by 64, which gives you 32. The ratio is 32. 32 is the answer. These are the questions I have selected recently asked in JEE mains and NEET exams. 4 identical discs, each of mass m, diameter is a, are arranged in a small plane as shown in the figure. If the moment of inertia of a system OO prime is x by 4 ma square, then the value of x. Let me give the numbers first. Let me select that. Let me change the color for a while. This is sphere 1, this is sphere 2, this is sphere 3, this is the sphere 4. Let me calculate moment of inertia of each sphere about a given axis. Okay, I am talking about I1. I1 nothing but moment of inertia for first sphere. First sphere given axis is the diameter. That is a disk. Already you know this is mr square by 4 m. But diameter is given a. So radius is a by 2. Mr square by 4. And if you simplify this, you get moment of inertia of a first one is m a square by 4 into 4, 16. This is also same that of moment of inertia of a third sphere also. Right, because see, first sphere and third sphere are identical. You look at the axis passing to the center and it's a diameter. Now you calculate moment of inertia of a second and fourth. So I can draw one more parallel line like this. Sorry, 1 second. Exactly parallel line that is passing to center, passing to center. Then you can write IOO prime is equal to IG plus mx square. Now Ig again same, it's about the diameter. So diameter is we calculated as m a square by 16 plus m into this distance is again the radius. The radius is a by 2, a square by 4 because x is a by 2. Simplify. If I take ma square is common and LCM 16, 1 plus 4, it is 5 ma square by 16. And this is also moment of inertia of fourth and moment of inertia of the second also. Because see, if I draw the one more parallel line to this, moment of inertia of the second disk also same that of the fourth disk. Now summation is the answer. See now, see moment of inertia of total moment of inertia is moment of inertia of first and second, third and fourth. So this is ma square by 16 multiplied by 2 I1 and I3. Again this is ma square 5 by 16 multiply with 2. So you left with, if I take ma square common, left with 1 by 8 and 5 by 8, which gives us 6 by 8 m a square. But here denominator 4, nothing but I can say 6 by 8 is equal to x by 4 according to the given data. I got 6 by 8 ma square. He said x by 4 times of ma square. What is x value? I equated them. Then I'll get 4 ones, 4 twos. So x is equal to 6 by 2 and x is equal to 3. So x is equal to 3. This is the way to calculate moment of inertia about given axis. This is again I used parallel axis theorem only. I calculated moment of inertia of a disk 1 mr square by 4. That is r value is a by 2. So 4 4 16. It is also same that of third. Similarly I applied parallel axis theorem to calculate moment of inertia of a disk 2 and disk 4. About own axis it is ma square by 6. That's what we calculated. And the perpendicular distance is equal to the radius of the disk, that is a by 2 whole square, a square by 4. So that LCM gives 5 by 16 ma square. LCM is 16, 1 plus 4, it's a 5. Then calculated ratio. Now this is the question which is very important. This question asked in recent JEE mains. You can expect the same type of question in advanced exam also. So please concentrate on this. A sphere of radius r is cut. One second. A sphere of radius r is cut from the larger sphere of radius 2r. You can see the light blue color whose radius is 2r and this radius is r, smaller sphere. Now this one to here it is a 2r. That is what. From the bigger sphere of radius 2r and the smaller sphere of radius r cut. Then the ratio of the moment of inertia of a smaller sphere, moment of inertia of a smaller sphere, let us suppose smaller sphere, to that of the rest part of the sphere, Okay, I look at this problem like this. I have a bigger sphere of radius 2r and I have a smaller sphere of radius r. Then I'll subtract smaller sphere from the bigger sphere. Then I'll get the rest part after curved out. Let me calculate first mass. What is the mass of the smaller sphere compared to the bigger sphere? Now, without knowing mass, we cannot calculate it. That's why, but moreover, it is uniform solid sphere. Total mass by total volume, that is 4 by 3 pi 2r cube according to the picture. Given data, this is m prime by 4 by 3 pi r cube. So which gives you m prime is equal to m by 8. Right? Let me calculate about a y-axis mentioned. Y-axis nothing but this, about this axis. This is the y-axis. Right? Now let me concentrate on smaller part first. Then again I apply the parallel axis theorem. This is y-axis. This is Ig. You know, moment of inertia about any axis which is parallel to the center of gravity. I can write about center of gravity into mass into square of the distance. This mass is m prime. Let me calculate that. About own axis Ig, diameter 2 by 5 m prime. M prime is m by 8 r square. Radius is r square. This is the moment of inertia of the cut portion. I mean dark blue portion whose radius is r plus m prime. M prime is the mass of the smaller sphere, that is m by 8 into the distance between these two axes. How much? It is r. So r square. Let me calculate mr square common. 2 by 40 plus 1 by 8. Take LCM 40. You left with 2 plus 5. 2 plus 5, 7. 7 by 40 mr square. This is the moment of inertia of a sphere of radius r is cut from the bigger sphere of radius 2r. I calculated moment of inertia of a smaller sphere about y axis. Right? He asked ratio of smaller sphere. We have done with the smaller sphere to that of the rest part of the sphere, not full sphere, rest part. Then how to calculate? We'll come here. This is moment of inertia. About this axis you want actually. This is the bigger sphere. This is the smaller sphere of radius r. Let me take minus whose radius is 2r, whose radius is r. This mass is m. This mass is m by 8. Okay, that's what is equal to the bigger sphere with curved portion. I want moment of inertia about this axis. About that axis, rest part. Already I calculated moment of inertia of the smaller portion. How much I got? That is mr square by 7 by 40. Correct. Now let me calculate moment of inertia of a bigger one. What is moment of inertia of a bigger one? That is about its own axis, diameter. 2 by 5 mr square. 2 by 5 m into r square. This r is radius 2r. So 2r square. So mr square 4. 4 to 8. 8 by 5. This is the moment of inertia of a bigger sphere. How much is that? 8 by 5 mr square. To get the cut the rest part, I calculate moment of inertia of a bigger sphere minus moment of inertia of the smaller sphere. Because it is a scalar quantity, you can subtract directly. You left with rest portion. How much is that? Subtract them. M r square, if I take common, 8 by 5 plus 7 by 40. Take LCM 40. mr square, LCM is 40. 40, 88, 64. You should subtract, not addition. This is subtract. Subtract minus 7. Right? 64 minus 7, it is 57. So what is the moment of inertia of this? 57 by 40 mr square. What he asked? He asked moment of inertia of the smaller sphere to that of moment of inertia of a rest sphere. So that is smaller sphere is mr square 7 by 40 divided by mr square 57 by 40. So you left with what? 7 by 57. This type of questions you can expect. Let me go through back to the case. So 5 by 57. Option A is correct. This kind of the questions, especially you can expect in JEE mains, sometimes even in JEE advanced also. This problem is not just based on simple one formula based. No, it is application. You should know how to calculate moment of inertia of a rest part. Before that, you should know the mass ratio, mass of the smaller sphere with respect to the bigger sphere in terms of the bigger sphere. And see, this again I used parallaxes theorem. So to be perfect in moment of inertia concept and problems also, you must remember list of the moment of inertia of different objects about their own axis. Own axis means passes through center or perpendicular to the body. Once you know, then you can calculate moment of inertia of any body about any axis using two theorems. One is parallaxes theorem, second one is perpendicular axis theorem. Most of the problems we have done today is not directly about given axis. I used parallel axis theorem to calculate moment of inertia of a given axis. Thank you so much. youtube.com, that is @ time for IITJEE and NEET. Subscribe and do watch the videos to get more clarity on the concepts. Thank you.